Morning, and thank you for joining us in the Advanced Materials and Supply Chain Innovation session. My name is Michael Lobsinger with the Center for Economic Growth, and we are the Regional New York Manufacturing Extension Partnership Center for the New York Capital Region. And I'll be your moderator for the next 15 minutes. We have a very impressive lineup of panelists today, and I, for one, am looking forward to an exciting discussion with them. On today's panel, we have two representatives from leading advanced materials R&D centers in New York State, Michelle Vanderwall, and with the Cornell Center for Materials Research, and Devin Shipp with the Center for Advanced Materials Processing at Clarkson University. Also joining us today on the corporate side is Andrea Madho with Lab 141 and Ashton with LC Drive, who will share their experiences on the topic. So this session is part of the NYSTAR Innovation Asset Showcase, which is focusing on a number of different high-tech industry clusters and highlighting key capabilities and innovations in New York State with a focus on how companies can leverage the robust R&D ecosystem supported by Empire State Development Division of Science, Technology, and Innovation, also known as NYSTAR. So supply chain is top of mind in the manufacturing sector. At CG, we see many of our clients struggle with the supply chain, particularly early on in the year, with factory shutdowns in other parts of the world. So we're here today to talk about steps companies are taking to increase supply chain resilience in the long term, including the role that advanced materials can play in seeking to substitute the inputs for typical source overseas items. So before we kick off the discussion, I'd like to orient you briefly to some housekeeping matters. So if you have any questions, please submit them in the Q&A function that you'll find in your banner at the bottom of Zoom, or maybe even at the top of the screen. Your mics will be muted and chat is disabled. So please use the Q&A function to ask your questions. So let's get started. I'm really excited about this. What I'm going to do first is I'm going to go through and have the panelists actually introduce themselves a little bit and their organizations. So let's turn it over first to Michelle.
Yeah, thank you, Michael. Yeah, thank you, Michael, and thanks for the opportunity to present the CCMR. So we are a Cornell Research Center dedicated to advanced materials, but the Industrial Partnerships Program, which I direct, is funded by Empire State Development, NYSTAR. So our mission is to support New York State businesses. And to do so, we provide access to experts, material scientists, and instruments in order to help companies and validate their technologies and optimize prototypes with the ultimate goal of bringing products to market.
Excellent, thank you. Next, we'll turn it over to Devin.
Thanks, Michael, and thanks to NYSTAR and FuseHub for putting this panel together. So I am the director of the Center for Advanced Materials Processing, or CAMP, at Clarkson University. And our main goals are to facilitate the formation of alliances between Clarkson faculty and researchers and industry corporations and government entities in New York State, and basically help them in applying science and engineering technology developments in the improvements of products and developing new understanding and new materials to help their businesses.
Excellent, thank you, Devin. Andrea, welcome.
Hello, I am Andrea Madho, co-founder and CEO of Lab 141. For clothing brands, Lab 141 provides seamless small batch online sales with integrated 48-hour on-demand manufacturing shipped direct to consumer, while offering consumers better fitting clothes with 5,000 proportional body fit options. No pre-made inventory means less waste throughout the supply chain process and limited environmental impact.
Great, thanks, Andrea. I'm really excited to hear more about your company. It's a very unique approach you take to your supply chain. Next, we're going to go to Ashton.
Good morning, everybody. My name is Ashton Singh. I work at LC Drives. I'm the senior procurement analyst there. At LC Drives, we're working to bring the next generation of electric drive motors to the world. basically our electric drive motors are going to change the industrial, marine, and renewable energy fields.
Excellent. Thank you very much, all of you, for joining us today. We're going to open up with some questions here that we have prepared, and I'm going to start with Michelle and Devin. Maybe we'll start with Michelle first. So Michelle, as companies rethink their supply chain for long-term resiliency, how can material science help? And maybe even go a little bit more into talking about your facilities, your instruments, and what it allows manufacturers to accomplish.
So some of the issues, the supply chain issues that companies face are, one, shortage of supplies, two, delayed deliveries, but also poor quality of the materials that they receive. And our resources are resources that companies generally don't have in-house: experts, faculty members and students, and instruments. Instruments that they don't need to use on an everyday basis, which are expensive, which are complex to use and maintain and optimize some procedures. So that's what we provide to manufacturers. And what we do with these assets, faculty, experts, and instruments, is help them screen the materials that they receive from suppliers. But we can also modify these materials. We can create alternate materials, or because of this network of companies we work with, we can also help them find other suppliers eventually. And finally, we can also help them, not so much in the external supply chain, but in the internal supply chain, in helping them optimize different steps of the manufacturing process. And for example, if they face sudden occurrence of impurities or failure or cracks, that's again where we can help. And I will give you one example from the start. So we worked with a New York State company, small business, but a worldwide supplier for the hospitality industry of these small shampoo bottles that you find in every hotel rooms. Their bottles were cracking. A new batch of bottles were cracking. So they went back to their polymer plastic supplier who said, nothing has changed in the formulation of the polymer. This bottle should not crack. It's your process of, filling up the bottles, sealing them. It's not or polymer or plastic. So they sent us samples of plastic bottles which had cracked to compare to samples which had not cracked. And we conducted a simple analysis using a calorimeter and analyzing the amount of heat necessary to change the structure of these samples. And it enables also to detect the degree of crystallinity of these samples. So what we could observe is that the bottles which had cracked had a slightly higher crystallinity than the bottles which had not cracked. So the company, using these results, could go back to their supplier and demonstrate that they had to reformulate the plastic. So again, to say a few words about our faculty, our experts and instruments, because we are a Cornell-wide center, we provide access to a wide range of expertise, from textile, fiber science with Lab 141, to electrical engineering, etc. So we can help companies from multiple industry sectors, for example, electronics, food, even food, plant science, as well as chemical and metal manufacturing, which are some of the biggest top manufacturing employers of New York State. And in terms of instruments, we have all of the instruments necessary to develop, process, analyze, characterize materials, image materials. So I could elaborate more, but about the range of instruments, let's just say that all of the instruments are listed on our website, as well as rates, policies, how to become users. And we implemented, of course, new procedures because of the COVID, in terms of less people in the labs, cleaning more thoroughly all of the instruments between usage. And these instruments are open to industrial users. So we train technicians from industry. And that's really also very important for companies, for example, which want to control their process, don't want specifically us to know which materials they are developing. So there is no issue of IP. So our labs are open, and I hope more manufacturers, 43 companies used them last year. So we hope to see more and help companies solve their supply chain issues.
Great, thank you. Devin, I'll kind of repeat the question. Companies rethinking their supply chains for long-term resilience. How can material science help? Talk a little bit about your facility and instruments, your expertise, and as well as an example, if you have one you could share.
Yeah, so Camp at Clarkson has a long history in colloid, nanoparticles, and surface engineering, and so on. And so it's amazing just how frequently particles influence our lives. This includes even the pandemic, obviously, we're going through at the moment, and I'll touch on that in a minute. But really, what we can offer at Camp is expertise in a wide range of materials, both in the synthesis and in the processing and the characterization, in addition to computational methods. And so there is often a case one can see where doing some computational analysis or sort of more theoretical approach to solving problems can be very, very helpful with regard to designing new materials and overcoming issues. So Camp is a university-wide center. We have faculty actively engaged in work with companies from electrical engineering, mechanical engineering, aeronautical engineering, chemical engineering, chemistry, physics, and biology even. So a lot of companies that we work with come from aerospace, semiconductor backgrounds. Almost anywhere there's a material science question, faculty at Clarkson can certainly help out. So we are, it's one area that I can, as an example, I can provide. We're able to help is in the semiconductor manufacturing area. So there is a strong presence, manufacturing presence in New York State, and Clarkson faculty with their expertise in the colloids, nanoscience sort of area have been leaders in the field of something called chemical mechanical planarization, or CMP. And a lot of that technology is based overseas, Asia in particular, but having that in-house expertise here in the state has benefited several companies. And I think that's something that certainly can be leveraged further as the state looks to expand that particular industry with, let's say, the hard drive manufacturing industry coming on board as well. So there's several areas that Camp and faculty at Clarkson can certainly help out.
Great, thank you very much. Andrea, welcome. The Lab 41 has taken this radical approach, I think, to supply chains with implications for inventory, sustainability, shift in your business model. Can you tell us a little bit more about that based on your introduction? It's kind of exciting. So
it's a passion. Our business is absolutely it's passion. So thank you, first of all, for having me and Lab 141. Just a little bit of quick background. I think it's always important to understand why each of us is here and why our business exists. I'm a plus petite, short-waisted woman. And a few years ago, I went to a shopping mall to buy clothes, and I couldn't buy anything. And I'm the average American woman. And rather than start my own fashion brand, I asked, how are clothes made? What are sizes? How does it all work? And why doesn't it work the way 3D printed objects are? One item, redimensioned, and then cut on a small CNC 3D printing table. And that's what we invented. We see the world changing. Traditional sizes and inventory, as we're seeing through COVID, are bankrupting lots of businesses. So Lab 141 started by re-evaluating and reinventing the full supply chain. And so I have to do a shout out immediately to CCMR and Michelle, because as a fashion tech advanced manufacturing startup, we did not have the resources to really launch properly. And we were able to leverage exactly what Michelle talked about at Cornell CCMR, the faculty, the instruments, the materials. We did a couple of projects with an amazing professor, Professor Netravalli, who's a professor of fiber science and fashion tech. So we were looking at different materials for seam testing. So right now we're all familiar with people sewing things on a sewing machine, but the future is not millions of people hunched over sewing machines. With CCMR, we were able to test some materials, and they did seam strength testing on adhesive bonding materials. They had some of the equipment, and our amazing team even looked at buying additional equipment to support our efforts. So as a startup, everyone understands raising venture capital and going to get services, but there are so many services that are available in New York State to leverage to help startups like ours. And CCMR was integral in that. But just on another personal note, one of the things about working with CCMR or some of these other resources in New York State is you have instant international credibility. When we say we're partnered with Cornell University, I mean, we were finalists in the Tommy Hilfiger Fashion Frontier Challenge. We've got some global brands. You say CCMR, you say Cornell, and all of a sudden we're world class, even though we're a startup. And a quick shout out to Clarkson. I did my TED Talk at Clarkson. So one of the other things that's, there are great resources in New York State, but it's more than just institutions. We are all humans here. And there are so many relationships that can be leveraged and expanded through NIST, through Fuse Hub, through all of you. So I would encourage any startups that are listening in to take a good look and develop relationships with all of these organizations right here, because there's a huge ripple effect. And not to hog this completely, but one of the fringe benefits of the relationship with Cornell is they were, because of their long and wide and deep roots, they were able to introduce us to our first customer. And that wasn't part of the agenda. That's just because of the relationship. So we are absolutely grateful for all of these resources today, because we certainly have taken advantage of everything.
Nice, thank you. You bring up a very good point about developing relationships. You know, supply chain in itself is networking. It's developing relationships and building those relationships and trust within your supply chain. You know, people are so used to just going out and finding a supplier and sending them drawings and getting something back, when you really want to develop a deep relationship with them, and multiple ones for that matter. So thank you very much for that. Ashton, welcome. Thank you for coming. The question I have for you is, you are actually heavily involved in some of the early supply chain development with your company. And, you know, I'm really curious about, manufacturers in my mind can feel locked into their current supply chains with certain processes and equipment that may be moved offshore that's no longer there, and hard to find domestically. You know, what resources did you tap into or utilize to help build out your supply chain, and what unique capabilities did you find?
Yeah, thanks for having me, by the way. I really appreciate it. Taking this job was the first job I had out of the Army. So obviously running a supply chain in the Army versus corporate world was vastly different. So I didn't have a lot of the networks and resources on hand that I did that maybe somebody more well-versed in the supply chain world did. So I had to leverage a lot of things like ThomasNet, Thomas Register, and work through my resources at Clarkson and stuff to kind of build these relationships. And obviously, LC Drives was initially doing a lot of sourcing offshore in China, which made things pretty difficult. I did a lot of traveling there. So just using it, we use a lot of Google just to find suppliers and resources like that. That was one of the main things. And then as we started to build the supply chain, we brought in people who have established connections through New York. And that really expanded the supply chain base that we have in the US, which has helped react to some of these like world events such as COVID, and everything going on with shipping and tariffs and everything like that. So we've been able to kind of reshore a lot of the supply chain into New York specifically, because there's a wide variety of suppliers that have the capabilities to do the harder things that we need to do and do it better than China and some of the other suppliers that we used to use.
Great, thank you. You know, and to that point, you know, why we're here today at this NISTAR Innovation assembly today that with everybody is that these assets, over 70 of them, all have some relationship with manufacturers across the state and researchers and resources across the state. So tapping into them when you have some deep supply chain questions, there's a lot of assistance that can come about that. And even the MEP program
the Manufacturing Extension Partnership Program that I'm part of, you know, if we can't find it then in New York, we have a broad national reach that we can also do. And a lot of our universities are also working nationally with other universities as well. So I'm glad you took advantage of that. I'd like to go back to Michelle and Devin, because it was, you know, a little bit of 3D printing and stuff was mentioned by Andrea. And I'm going to broaden that just a little bit. So, you know, Michelle, let's start with you. And you know, what role does advanced manufacturing technologies like robotics and additive manufacturing have in reducing the resilience on possible complex international supply chains, as Ashton had mentioned? And how are your centers making it possible for companies to pivot in incorporating these technologies?
So advanced manufacturing, of course, includes, you know, new technologies, innovative technologies that you bring to the manufacturing process. And additive manufacturing and robotics are, you know, two of them. And of course, additive manufacturing is very, very interesting for many businesses, and for example, for Lab 141, because it enables to decrease inventory costs, for example, and you produce, you know, as you need, but also you can use multiple types of materials, not only polymers, but also metals, ceramics, nano materials, as well as biological compounds or materials, because you can decrease the number of parts. And famously, I mean, GE decreased the number of parts of its turboprop, catalyst turboprop engine from 850 to 12. So you decrease also the occurrence of failure because you have less connection points. So for all of these reasons, of course, these technologies are, you know, very important for all of the manufacturers now. And again, how can we help us as a research center? We can help again in analyzing materials, in helping companies screen the materials they are using, like adhesive for Lab 141, testing them, optimizing process. And again, because we provide access to instruments that, as Andrea mentioned, companies don't have in-house. Again, they don't need them on an everyday basis. So another company we work with from Ithaca is a supplier of 3D printed parts, plastic and metals. And they came to us because as they were negotiating with a major customer from the aerospace industry, they needed to analyze the parts, demonstrate to this large business that what they were developing had the required properties. So we did a bunch of analysis for them, including, you know, hardness test, electron microscopy, X-ray diffraction for structure on stainless steel test tubes, 3D printed using different 3D printing process parameters. And this enabled the business, again, to demonstrate, bringing all the analysis to their potential customers to demonstrate that this part had the required properties. And therefore, they were able to finalize their contracts. So we can help again in analyzing materials using instruments, but we can help also in providing access to faculty. And specifically, if you want to test new type of materials. So we have faculty members working on biological compounds, for example, for tissue engineering, for 3D printing for tissue engineering with applications, for example, in wound treatment, using, for example, collagen. Collagen is in most of our organs. It provides a structural integrity to the skin, and some faculty in biomedical engineering are modifying collagens in order, again, to optimize process for tissue engineering. We have faculty working on metals, so you're printing on metals. We have faculty working on ceramics, new ways, developing new process to create ceramics with specific pore geometries by using resins loaded with ceramics and using a new process, digital light processing lithography, and exposing layers of resins to a light pattern. So the resin layers will solidify according to this pattern. They will then be put in a furnace to burn the resin and cure the ceramics, and therefore obtaining ceramics with specific geometric patterns. We have also faculty working on robots. Robert Shepard in mechanical engineering is a director of the organic robotics lab, and he's developing soft robots, really very intriguing and interesting research, for example, for application in prosthetic limbs. So integrating two soft materials sensors to provide specific signals, for example, a touch sensation. And he has been, for example, he has been developing a prosthetic hand able to grasp objects. And again, optimizing the 3D printing process because of the specific materials that he has been using. So what we can, again, bring to these businesses is expertise and access to instruments, and helping them, as we did with Andrea and Lab 141, test new materials and make sure that their process is optimized and ready for commercialization.
Great, thank you. Devin, same question about, making these technologies available, obviously, to companies. Any good examples of actual adoption of that and then bringing that in and scaling that?
Yeah, so obviously additive manufacturing is the way of the future for many different applications. And so Clarkson faculty have jumped on board in terms of applying their expertise to a number of different areas. One of them that is really critical is really monitoring, doing quality control, let's say, of the additive manufacturing process. So Professor Chetan Kaier here at Clarkson is developing real-time processes in which they can monitor the production additive manufacturing using photoacoustic techniques. He's working closely actually with another cat at RIT, the AM Print, which is another one of the centers. I think there's another panel discussion, also part of this in a showcase that's happening today and tomorrow. So, but knowing when and how something is being made properly. So if things are done on an individual basis, quality control is critical, and being able to be sure that something is being made and then there's no failure, no points of stress points and so on in the material is critical. Another area that is, I think, really going to be the way of the future, and Michelle sort of alluded to this with the robotics, is sort of artificial intelligence or machine learning, sort of being able to bring on board sort of how things can make themselves almost. So, getting not just using robots or making robots, but how do the robotics actually allow us to produce things in a much more automated fashion. And we've got, there's two computer science faculty, Clarkson, Sean and Natasha Banerjee, that are working in that space with a small company, Additive AM Innovations. There's a spin out from Clarkson, really trying to look at how to look for mechanical deformations in the microscopic length scale. So as metal additive manufacturing is developed, again, we need to go back to sort of how to determine when something is going to fail or when is it successful. And I think there's a big field in front of us in terms of AI contributing and machine learning contributing to that particular area.
Both of you talked a little bit about quality and things that we've seen with some businesses who do some things in very small titanium parts that are powder cast, and they have thousands and thousands of them, and they have to inspect every one of them, and how can AI assist in identifying potential issues and using vision technology and things like that. So there's a lot of things going on out there. You just ask, you'll learn about what's happening in research and the tools that are available.
Yeah.
Thank you. Andrea, we're going to come back to you. The thing I see is that, how do companies adopt similar methodologies and things as you? So, what are the analogs to your model of manufacturing and how that could push to other manufacturing industries? Thinking outside of the box and how they make their products. Like, what lessons do you have?
What a great question. I suppose you have to harness your own frustration. I think real change comes from frustration. And one of the things that Michelle talked about was that great GE example of changing, of thinking differently in order to manufacture differently and creating new supply chains. For us at Lab 141, we saw personal individual problems, but was actually part of a much larger problem. So in the world right now, we're seeing post-COVID, traditional methods for manufacturing, like creating tons of inventory in Asia and coming back, it just isn't working. One of the things that Ashton just talked about is smarter advanced manufacturing. For us, additive manufacturing has been a key component of our solution. But in order to create jobs of the future, you've got to rethink the way things are done. So I think any crazy technology idea today is probably the future of that actual technology. For us, when I use the example of the principles of 3D printing is what we use as the basis of our business, we're not 3D printing clothes. We are using the principles of making one-off at scale using technology. And I think for other companies, it's how do we solve the problem differently, efficiently? Because this is the way we're going to bring those jobs back to America and just do them smarter, because we cannot compete doing business as usual. It's got to be smarter. It's got to be innovative. One of the incredible values, Michelle talked about new materials. Well, part of our development with CCMR was to use existing materials in a new way, as well as developing new materials. So again, I want to just talk about relationships. One of the great things for us in relation to Fuse Hub as well, and CCMR and NISTAR, are the relationships. We were able to get a team. Essentially working with CCMR wasn't just faculty, it was a team of experts that were working with us. Again, as a small startup, normally we'd have to hire consultants and all kinds of people, but that relationship with CCMR brought that all together. So it's analog thinking just cannot work for the future. It's how do we leverage resources? How do we take advantage of everything around us, including existing relationships and new relationships? Fuse Hub's a great resource for us for bringing together all kinds of New York State resources. So I would say new thinking requires new thinking all the way around. And even something that doesn't make sense today, well, part of the process of development is making sure that it does make sense in the future.
Great, thank you. That was excellent. You know, one of the aspects that you mentioned too, and I think with COVID, you know, we're seeing impacts in the supply chain because manufacturers are now having back orders because they've had to change their shift, spread people apart, they've lost some workers, and those are not coming back into the workforce just yet, you know, and you know, there's an opportunity to also look like, how can we do this different? How can we add technology to robotics and assist people, or you know, maybe do some 24/7 operation on automation? You know, and these resources are really great for exploring those things and trying to look at things in a different way. I'm going to turn to Ashton here. You know, you again experienced a lot of this in developing a supply chain, you know, in an industry for yourself. So, you know, developing a supply chain and managing that supply chain can be complex. Identifying your gaps and assessing the weaknesses, contracting. You know, for small and medium-sized manufacturers, this often falls to the fighting fires. You know, and so you know what can they do to kind of like, you know, move forward and take an active role in their supply chain?
Yeah, so developing the supply chain is a huge challenge, especially with our company and the rapid growth trajectory we're on right now. It seems like almost you get a system set up, and then that as soon as that's set up, it's already obsolete just because of the volume. So it's taken a lot of creativity and a lot of hard work to get it up and keep it going. So some of the tools we use, obviously implementing an ERP system is not viable for every single startup. So you have to use some creative solutions. For instance, we've pretty much got a well-running ERP system using Google Sheets. It's taken a lot of creativity to get that going. And there's a lot of other things that people can use, such as open source ERP systems like Apache or something, if you have the capability and the know-how to make those work. And pretty much the biggest thing is getting these systems in place so that way as you experience the growth, you're not struggling to keep up and fight those fires that supply chains run into, right? So a lot of the techniques we use are just really deliberate actions when we go into setting up relationships with suppliers, establishing our incoming material flow, going to QC, getting put onto the manufacturing floor. That a lot of that's really hard work up front, and you got to kind of balance that, getting the parts and materials in to feed manufacturing without rushing to failure. And we have all these parts in, but now we've kind of soiled the relationship with the supplier because we're accepting bad parts, stuff like that. So it takes a lot of deliberate action, like, hey, I know we're all rushed. I know there's a lot of things going on, but we need to really sit here and develop these systems and processes so that way in the future, when we've hit that growth level we want to be at, we're not trying to go through and reestablish all these systems. And that takes a lot of work throughout the organization, both in the production side and the quality side, and getting everybody on the same page. And then a lot of the resources that we use, a lot of it, especially right now, is just staying on top of current events. So if you're an international supply chain, really staying on top of the tariffs, really staying on top of news. The tariff situation is like a rapidly evolving thing. So like every month it seemed like you would have new tariffs. So you have to stay on top of that. And then obviously within the country itself, dealing with logistics issues every day is a reality right now. It seems like something coming out of every state or coming in, there's always delays. So you have to start building those contingencies into your production plans and your forecasting to really make sure that you're not going to run into a rough situation because of the black swan event that we are living in. So those are some of the kind of things that we keep in mind and really aim to work on here.
Mm-hmm.
Great, thank you. We are going to get into our Q&A session. If there's any questions from the audience, so please just post them in the Q&A. I am going to ask a couple more questions to Michelle and Devin. Could you, if you want to elaborate or share a little bit more, Michelle, on another project that you might have worked on with a company and how you assisted them?
Yes. So again, what I want to emphasize, and listening to Andrea and Ashton, is that we work, even if we here, represent, for myself, Cornell, for Devon, Clarkson, we collaborate. And what everybody has been, talking about up to now in terms of, being a team and, working in this ecosystem, generated by NISTAR. It's very important for us also to demonstrate to the companies we work with that, I'm not going to talk only about Cornell if the expertise doesn't exist at Cornell, and Ashton and Andrea, will be introduced to Devon or to some of the other institutions we have been working with. And that's something I think, all the manufacturers, should be aware of, that of course, we would rather market for us Cornell University, but it's very important for us that the companies we work with, are offered all of the opportunities to optimize basically their process and bring these new products to market. Again, I think the assets, we represent, and Devon and I are, this wide range of expertise. And that's why we use as a logo any company, any challenge, for example, for CCMR. It's mimicking Cornell logo, any person, any study. And really we aim at helping, any company, established businesses, established traditional manufacturing business, as well as, the Andrea of the world, to develop, validate their technologies and bring their products to market. I can give you multiple examples, but what I want to say is that we can also as well, use the resources existing around the state. For example, we were able to introduce companies to other suppliers. To give you an example, a company developing a startup, a high-tech startup, developing surgical devices, fluorescent surgical devices to facilitate the visualization of tissue for surgeons. So these tools fluoresce, and basically, it's easier for the surgeon to put them under another tissue that they would cut and, be able to conduct the surgery, more accurately. So this company simply was mixing dyes to a polymer matrix for this device. And they were relying on a global chemical company. And of course, the portfolio of this company was limited. And there was not much flexibility in the relationship. As Andrea mentioned, relationships are very important. But we had worked many years before with a small New York State dye manufacturer from Binghamton. And we introduced these companies to one another. And they are now discussing different dyes formulation so that the surgery company will be able to test multiple dyes and really optimize their device. They would not have been able to do so without without CCMR, introduction, and they would not have been able to do so with this major business, which was not as flexible as also, close in terms of distance as this New York State business. So again, it's not only using our own assets, our faculty and instruments, but also because of this network and of companies we have been working with and service providers such as FuseHub and other institutions brought together by NISTAR that we can even help better businesses.
Good, thank you. Devin, anything more you'd like to share?
Yeah, I echo exactly what Michelle said, and to sort of continue the theme of developing relationships and so on, I would also add that the CATs, I think, all do a great job of training students. This is like a workforce development kind of process one could imagine. So often there's graduate students or undergraduate students that work on some of these projects along with the faculty, and companies can leverage that these projects into potential hires. Clarkson has often had graduate students go and work in the companies, spend 6 months, maybe 12 months there. Faculty have even worked in some of these companies. I spent myself 6 months working at Bausch & Lomb a couple of years ago. So these kinds of relationships, they're not just one and done. Send a sample and get it analyzed and send it off. It's usually much deeper than simply that, and I think that really helps the company's technology footing. Once it helps them understand the technology and what they can really achieve, and develops a network.
Yeah, I definitely come across companies sometimes who, they have an approach for some of their R&D and they take it, but they're not having an outside person look at it.
Yeah.
And the experience of these assets, you can see like where the roadblocks might be. Like, we've run into this before. You want to be careful that we can help you with that. So, a question did come in. And this may have a little AI stint to it or not, but so obviously the more data and intelligence that you can gather across your supply chain, the more you can kind of understand or mitigate the risks that are there. What tools or resources or information is missing? This question is for Andrea and Ashton. Is there information that you're not getting or can't find, or it's difficult to find? So let's start with Ashton on that one.
Yeah. So one of the biggest things we're missing, especially offshore and onshore too, is like actual hard lead times. So there's like a flash to bang when you place an order, like, hey, we placed the order, this amount of time is processing, and then okay, like the 29th at 10 a.m., the mill started cutting. And that kind of data comes really, gets really important when you're trying to run a lean manufacturing company. And especially when you're like getting parts in. And then also is really important right now in the stage of like a really research and development heavy manufacturing organization, because we know that the prototype model we're building now is not going to be the commercial product that goes out the door in a year. So we're trying to balance that with ordering the parts that we know are going to go into the commercial model versus the prototype parts. So that kind of information drives, plays a part into, okay, the engineering team's going to have this design out Wednesday, so we can expect to be building the newer version next week. So that kind of nitty-gritty detail is really important in that supply chain and engineering group collaboration. So that way we're not wasting money on parts that we know we're never going to use again. And that way we can drive profitability faster and sooner.
Nice. Andrea, for you, any issues with like gathering information out there? Are suppliers not sharing certain information? Capturing even competitor information, things like that. What's your view on, getting intelligence on supply chain?
I'm going to reframe this just a little bit to say,
Sure.
For us, COVID has been an incredible opportunity because companies have to do things differently. So we found that so many more companies are willing to talk to a small startup like us and provide us with information. So as bad as things are, there's also opportunity for doing things differently. So in terms of very large brands, some of the largest brands in the world have reached out to us to implement this process. And they've been very forthright and open about sharing some of their problems and where our solution might help them. So I just want to say that for us, and maybe because we're non-threatening to large brands, but we're also radical. So in terms of them sharing information, they've been very willing. And I've said it before, business as usual just isn't working. But the second part of this that I do want to say is, COVID is an opportunity, but speed to market is what we're seeing right now. Businesses have to do something differently. And so innovating and the willingness to adopt a new model, we're seeing all across the board within the fashion supply chain. So COVID is an opportunity, and speed to market, it's happening right now. Even in terms of our own development, we probably developed 6 months worth of innovation within 6 weeks at the beginning of the pandemic. We had to speed up because the opportunity is now. And we've been lucky to find those partners. And just because this is a New York State event that we're at right now, I just want to say, New York State, localized microfactory production is what we're advocating. And producing in America has a location benefit. Ashton just talked about tariffs. Well, there is no tariff if it's made in the United States. And that's one of the things that we're seeing some of the brands that we're talking to is really looking at American manufacturing again. And that comes back to information. They're willing to tell us that that's a priority for them. So COVID is an opportunity, and speed for development is happening right now.
Great. So we have time for one more question before we close. And this question is for Michelle and Devin. And let's start with Devin. Can you talk a little bit about IP ownership and sharing with startups and centers if you're developing, some new tech or solution together?
Yeah. So this is a common question that comes up, is sort of how does one handle IP? There's a lot of details that one can get into, but I'll try and keep this pretty short. But basically, Clarkson's approach to working with companies is, the company is going to be doing the manufacturing. Clarkson doesn't want to take over the IP and then have it sit on a shelf somewhere. So we try to be proactive, negotiate, hopefully some fair terms. Basically, we come down into sort of 3 categories. One, IP is already developed by the company, or at least they own that, and they share it with us to help us understand the problem that they wish to engage us with. Another one is the faculty member or someone at Clarkson is owning the IP, and then of course there's sort of joint developed IP. And again, we basically have to sit down and have a discussion here. This is where forming a relationship comes in, and one has to determine what fair terms for both the company and the university. But typically, the university will take the attitude that it's much better for the IP to be in the hands of the company so that they can do what the company needs to do in manufacturing.
Yeah, and I mean, I think Devon described very well, the process. Cornell has the same approach. For CCMR specifically, for example, the fact that we train industrial users on the instruments mean that we don't even need to know which samples, which type of materials they're analyzing. They come, they are trained, they bring their samples, they leave with the results. And, if they don't need any input, they leave with all of the data. And this solves, of course, all issues about IP. As Devon is saying, it's only when there is some input, when it's jointly invented, and most of the time when a faculty member is involved in the process, that there is then discussion about IP. And again, in a committee, analyzing also the background, intellectual property in order to determine, the ownership.
I just want to say something quickly. So of all the resources, we talked about resources in New York State and relationships. We actually worked with New York State Science and Technology Law Center, and that's a great resource for startups like ours. We actually worked with them on a small project, and they provided amazing insight. I mean, we have our own, we have a lot of IP filed. Part of the value of Lab 141 is that we're always innovating, but New York State Science and Technology Law Center at Syracuse University, great resource for startups out there. You should absolutely reach out because they provide, again, resources that you can leverage rather than paying for. So take advantage of the free opportunities out there.
Yeah, no, I'm happy Andrea mentioned Molly Zimmerman and the Institute. Yeah, it's a good resource for everybody.
Good. So with that, we're going to close. So on behalf of the panel and myself, we hope you enjoyed today's session. For any of you and any of our New York State manufacturers in the audience, if you have impacts in your supply chains or you're looking to shore it up or looking at reshoring, consider filling out our reshoring and supply chain survey. It can be found on New York MEP website, www.newyork.org. That's newyorkmep.org. This session has been recorded and will be provided to everybody in a post-email follow-up. After a quick break, the event will continue with 2 more sessions. All links to access the events can be found on FuseHub's website, www.fusehub.com. That's FUZEHUB.com. And with that, thank you, everybody, and have a great day. And again, thanks for joining us.
No, thank you.
Thank you very much.
Thank you.